You have a bag with a strict weight limit and a room full of valuable items. How do you mathematically decide which item goes in first? Imagine grabbing the item with the highest total profit. A 10-kilogram gold bar worth $100 looks like the obvious choice, but a 2-kilogram diamond is worth $50. Per kilogram, the diamond yields way more cash. Alternatively, you might pack the lightest items first to save space. You grab a 1-kilogram feather worth $2, but by filling your bag with cheap, lightweight items, you leave behind a 10-kilogram brick of silver worth $100. Building a strategy on weight alone or profit alone leaves your bag short of its true potential. We need a different metric. Instead of looking at total weight or total profit, we look at profit density, better known as the profit-to-weight ratio. When buying candy, you determine the best value by finding which bag offers the most pieces for every single rupee spent. By calculating exactly how much profit we get for every single unit of space, we guarantee the highest return on the capacity we have. We have a 50-kilogram capacity bag and items A, B, and C. Step 1. Divide profit by weight to calculate the profit-to-weight ratio, getting 6, 5, and 4. Step 2. Sort them. The highest ratio at the top dictates exactly how we pack. Take a moment to look at this sorted table. Can you calculate the absolute maximum before we do it together? Sorting the items by their ratio eliminates all guesswork. The problem becomes a strict mathematical checklist. Item A's 10 kilograms fits perfectly, jumping profit to $60. Next, item B's 20 kilograms goes in whole. The bag hits 30 kilograms, profit climbs to $160. Finally, item C is 30 kilograms, but with only 20 kilograms left, it won't fit. In a fractional knapsack, we break items. Dividing our remaining 20 kilograms by the item's 30 kilogram weight means we need 2/3. Multiplying 2/3 by C's $120 profit yields $80. Added to our tally, we hit the maximum profit, $240. Calculating the precise fraction of the final item ensures zero capacity is wasted. The formal pseudocode shows the algorithm making a single pass down the sorted list. Time complexity is O of n log n, as the initial sorting takes the most time. Space complexity is O of 1, requiring minimal extra memory. A heavy initial sorting step makes the actual decision-making process incredibly lightweight. For an exam, remember 4 letters, R, S, T, F. First, calculate the ratio. Second, sort the list descending. Third, take whole items if they fit. And fourth, calculate the exact fraction for the final item. Because the specific setup allows us to break items infinitely, we never leave empty space in the bag. Every gram of capacity is utilized, mathematically guaranteeing the optimal solution every single time.